Looks like we're live. So we'll do the usual test to make sure everything's working okay. Usual test. Come on. Test. Like we're live. Yeah, it's okay. So, done with that routine. So yes, this video I will title Push Gravity, which I did do some research on and was amazed at how there's absolutely nothing on the subject of push gravity that has anything to do with gravity being a push force. No videos whatsoever. Um, I did do this research in two ways just to see what YouTube does, in terms of the shenanigans and Google. Looking in a private window versus a window where they know who I am. And when they know who I am, one of my videos comes up like 8th or 9th. And when they don't know who I am, it comes up 200th. So it's just, why should people be served a different version of the internet? Why does everybody think that's okay? I just think that's such a bizarre. If we gave Microsoft the control and let them decide what internet you get to see based on its commercial value to them, everybody would say, "No way, we're not." Nobody would accept that, and they let Google do it. Just amazing. Everything's amazing in terms of how easy it is to underestimate how fucking stupid um, people and our civilization are. I mean, just you can just never underestimate, um, just how bad the dumb, ignorant shit is, how deep it goes. Anyway, the reason for this video, essentially, right? Something as simple as two words, push gravity. And there's an official song. There's some guy, W.C. Wright's Push Gravity, which actually has nothing to do with gravity being a push force that is moving towards the center of gravity, being pushed in instead of pulling. So it has nothing to do with the difference between push and pull. It has to do with some notion that I guess is the whole foundation for the electric universe, which is that somehow gravity's a repulsive force. That somehow asteroids are bouncing off of the repulsive force of gravity. I mean, it's just, it's in that category of people just can't be this stupid. I mean, it's so stupid. So anyway, so there's a ton of that shit. So that must be, like I said, that must be the foundation of all this curved linear bullshit crap, hyperboloid nonsense that these people are talking. Anyway, and then it gets into plate tectonics and all kinds of other subjects. But I mean, I even put it in quotes, push gravity, because when you type it without quotes, the results are even less relevant to the concept of gravity being a push force. Um, an external force pushing in rather than a pulling force. So I intend to make this video be some sort of reference on the subject. I mean, obviously there's a link to my website below where I explain push gravity, a particle gravity. The two, I guess, are synonymous in some respects, because obviously particles can't push if you're throwing particles. But the idea is that the push comes from the external pressure. And what you can do is create low pressure. So you can remove pressure. And by removing pressure, the external push pushes things together. So there is no attraction. There's just a lack of repulsion. Yeah. And so obviously this is exactly the opposite of the theme of everybody on planet Earth, apparently. Which is, bizarre. From my perspective, I'm going to just say it seems bizarre to me that this isn't more of a conversation. Just the idea, are we being pushed into the earth or are we being pulled? And it seems like lots of people ask that question, and it just seems strange that they all answer it the same way, even though there's nothing. I don't know why I was doing this. I'm trying to keep my brain from seeping. Because I just can't imagine how everybody can be so freaking stupid. So the conversation never really takes place. So anyway, the last 3 videos I've made are sort of on this subject. So I guess I'll post links to them below also, or something like that as a reference. The overview videos go into the subject. And it does get into this idea of how gravity works, in the sense that gravity is absorbing force. I would argue quite clearly. That's why the things are moving, is they're absorbing something that makes them move. You can't move for free, for nothing, for no reason. And so there's so many analogies. I've used analogies like schools of fish in the past and different things to sort of explain this idea that there's stuff inside of you that's dictating what's happening, and there's a lot of stuff inside of you. And it's the net effect of what's happening to that stuff inside of you that sort of dictates your motion. And you absorb velocity. And we call that acceleration. That's where your body is being changed and converted into something that has a velocity and a direction. That is, it's holding. It's having its battery charged, in the sense of having pressure in a direction. What I'm looking for, spread over your entire material form. So the pressure moves right through you, like pressure moves through the air, and fills you like a balloon with a bunch of equal pressure in a direction, net direction. And so, I mean, something, the simple things to point out is, okay, we know that bent space is kind of a cheap metaphor, but the truth is an external force were to create exactly the same force. So all of Einstein's equations work exactly the same if you, instead of pulling from a drain in the center, you just push from an external source. So it's exactly the same math. Nothing changes. So bent space, that metaphor, works exactly the same if you use an external pressure. Now, the only catch is, if you use an external pressure, you have more of an idea that the pressure runs out, that whatever pressure you create out here, you can consume, you can drain it so fast that there's zero pressure. And their idea of a pulling force, they can just keep making the well deeper. So the idea, if it's a pushing force, you can kind of understand it probably has a limitation. You'll run out of pressure. Where if they have a pulling force, they can just kind of make the well as deep as they want, deep, 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 deep. And that's where they get the theory of black holes and lots of things, is because the analogy, if you want to use that word, of bent space allows them to. Where if they were using an analogy of a wind pushing from the outside, we'd all know that wind has a certain strength. Tornadoes have winds of a certain number, 500 miles an hour. And that's as fast as they go. They don't go any faster. There's a limitation. And again, their use of the metaphor means they can just make things deeper and deeper and deeper. Where if it was a real force, that is something like wind, you'd know, no, it's a certain amount of pressure, and that's all. There's not more pressure. There's this much, and you can have less pressure in between two things. So you can have 500 pounds per square inch pushing in, and then between things you could have 400 pounds of pressure, and then things would be move towards each other. But you can't create more pressure somewhere in that system. You're stuck with the maximum amount, and that's as far as you go. And as I've explained, the real catch to this is that once you've used up all that pressure, say inside a very dense object, a very big dense object, and you've used up all the gravity pressure, the external amount of pressure you can impose from the external, and it's turned into chemical pressure, The point is that once you've used up all the gravity, so to speak, in the sense that you've used it to move a bunch of objects, so now the wind has been consumed by a bunch of objects that are like friction, that are, it's spinning like a tornado eating trucks. It can only eat so many trucks. It can only carry so much weight because each truck is slowing the wind down. Well, the same thing with gravity. The mass is slowing the wind down, slowing the pressure down in terms of how deep it can go. And the point would be is that the atoms in the center of that very dense thing wouldn't be getting any gravity. And the gravity is technically what's holding the atoms together. And so it explodes because the atoms lose their pressure and they expand. And when they expand, they force everything else to expand, and everything cracks and breaks and moves out. And then probably moves back in again. So again, you can explain everything. I mean, it really does seem that solar systems are vibrating things, in the sense that these are suns that explode, recontract, explode, recontract. That's why there's so many heavy metals, is because we're not taking stuff from other supernovas. We're made of stuff from our own sun's supernova. Our sun supernovaed, and then it recondensed, and then it supernovaed, and then it recondensed, and we're in that process. But anyway, that's speculation, not necessary for this conversation, or to make the points necessary in this conversation. So the real key point is this isn't some kind of bizarre idea that can't work. No, it's a real solid idea that does, in fact, duplicate Einstein's mathematics perfectly if you just reverse the source of the pressure. Instead of a vacuum, a pulling, you just make it a push, and it all works exactly the same. That's why they call it mock gravity. And it's a real viable contender as an explanation for what's happening here in the universe. And it's really annoying, that apparently everybody's terribly hostile to it for some reason. I guess it's because push just doesn't sound nice. Being attracted sounds so much more friendly than being repelled or being pushed. And so I guess they just can't deal with a push universe, even though our universe has every sign of being hostile, nasty, and pushy. There's nothing you can say. I mean, there's just no excuse that, these conversations aren't already way in the past, and that we've already established, that should already be established, that these are the facts of the circumstance, that there is no evidence saying it's a bull universe. And there's lots of evidence defending the idea that it has to be a push, because the push is the easy force. It's the dumb force. It's the simple force. The pull force has nothing to do with simplicity, nothing to do with elemental function. This idea of grabbing and pulling. Anyway, and it doesn't, the pulling thing doesn't have any innate energy. When you push something, it's innately energetic, in the sense that the energy is then the thing that has to move from one point to another point and hit something. So motion is really key to this whole argument about gravity anyway, but that's the key to the thing. Something hits something, and then that something moves, and that's the function of the universe fundamentally. So why would you pervert something so obvious into something very, like, how does it pull? There's no mechanism. You can't move towards it and pull it. You can't, you need energy to do that. The energy is built into something hitting something. And we know it has velocity. So I could argue that it's kind of obvious that photons have perpetual energy. They travel 15 billion years to get to our eyeball. You kind of know, well, 15 billion years worth of travel, I guess we kind of know it never runs out of gas. I guess we can figure that, right? There doesn't really have to be an argument about that, does there? Come on. These things never run out of gas, these photons. They just keep moving forever and ever and ever. And they're doing all this simple thing of pushing. and pushing in the sense of pushing things together and things that don't really want to be next to each other and creating, you know, matrices, mathematical geometries of different relationships that make things as close as they can get without falling apart. But structures, you know, structures held together by magnetic tension, but they're all under pressure. They all have to be made by pressure. They have to be made by a force that pushes things into each other and tests and says, well, can that stay that way? And if it stays that way because of this, because of the way the pressure is filtered and magnetism, I can't, you know, you have to go to the website to get some of this stuff about the fact that there's two kinds of force and there's two kinds of matter, and the magnetism is just a reflection of filtering gravity. So there's this one force, gravity, you could say, that's this force that doesn't have any specialness about them, except it's a mixture of two, you know, electron force, proton force, two round square. And those little bits are just randomly mixed and they're equally coming at us. And that pressure is filtered by a magnet. And by filtering it, I mean, all the squares come out one end, all the rounds at the other end, and those affect protons and electrons inversely, which creates the idea that you can let the pressure out, which means that you can have an electron and a proton and an electron, and all the electron pressure, the stuff that bounces back and forth between electrons, goes out the proton, and therefore the two electrons can get much closer to each other than they would be if they were free, because all the pressure leaks out. Anyway, I've explained this in previous videos, and it's sort of a distraction from the fundamental subject of pressure existing, of the push being the more essential force, the more elemental, rudimentary, fundamental. It wins the Occam's Razor Award, where pull requires something else. Pull requires something else besides just moving into something and hitting it. It requires something more complicated, some other mechanism. So push is obviously the winner of the Occam Razor Award for conveying motion, transferring it from one object to another. Yeah, I think that's a start here. Yeah, so I don't really have a direction I want to go here. Sorry, my voice is a little but I might get to a Bill Gaede video on the subject of motion, because he goes through a couple of hours of discussion of semantics to, you know, as if this is that complicated. I mean, as if we can't understand that we can't agree on an axiom for the definition, which is that there is truly three-dimensional space. You know, up, down, left, right, forward, back exists, and they have, you can just standardize that space, and you can just say things occupy, you know, a certain hunk of that dimensional space. They have coordinates, and motion is just defining change over time. And you can cut the time into as small as pieces as you want. You can make the checkerboard as small. You can make the little squares as small as you want. And you can make the size of the bits as small as you want. And it just has to do with how much resolution you get, how clear the picture is. And I guess I would argue that we don't need resolution finer than the fish in the school of fish. So once you see the fish in the school of fish, then it's pretty easy to say you fully are appreciating the full function of the school of fish moving. So in the school of fish moving, it's because each individual fish is moving different paths and different amounts in certain directions. And it all adds up to the school moving much slower than any of the individual fish. But you can, once you can see the fish, you can trace all of the reason why over time the school moved. And, you know, that's all the resolution we need. But that's the truth is there's a bunch of little squares in space. And in one moment, a thing is occupying a square, and the next moment or later, it's not occupying that square, it's occupying the one next to it. And there's certain rules about how fast you can acquire squares. You have to go through the squares to transition from one square to another. You have to do it contiguously. You can't jump over the dominoes, right? If you're a row of dominoes, you can't jump over the dominoes. You have to hit each individual domino in order. You have to consume the squares in order. So you just make your squares consistent with your time, and it doesn't really matter how you draw it then. You just make the time and the size of your squares coherent to each other, and you'll get a good diagram of motion. So it's not that complicated. So to spend 2 hours, I mean, come on. Now, let's, no. Anyway, all right, so let's decide where to go from here. Yeah, wearing an old shirt I forgot to hang. I painted this 20 years ago. Yeah. Fabric paint. Yeah, not bad. I paint better than this now, but yeah, it's not bad. His eyes need a little more. Yeah, not bad. Anyway, yeah, I just don't. Yeah, well, I'm just going to I'll see if there's any comments, and then I'll check the live chat and see if anybody's paying any attention. But that's the part of this that is kind of a waste of time, is the live part. I guess I would just let go. I can just make videos and, and pretend they're just regular videos, I suppose. So I guess I shouldn't bother attempting to get anywhere else. I don't know. Hi, Sand Oaken. What does that mean? I mean, it's just so incoherent. People are just so incoherent. They're not connected to anything rational at all. You people are just wobbling around in some kind of, you're like bobblehead weebles. I mean, you wobble and you don't fall down, and your head's bobbling. I mean, you're just not even close to being connected to reason and logic. You're just bobbling on it and wobbling on it. You don't do any of it. Sorry, but yeah. I mean, the last video was a perfectly good video. I thought, lots of great arguments in it. 3 likes. 3. I mean, it just doesn't make any sense at all. 3. Yeah, there's no excuse for that. 3. I mean, 10 dislikes and 3 likes. Over 100 views, 3 likes. I'm sorry. It just doesn't make any sense. Especially when there's not a single counter argument to a single thing I said. No comments. I mean, it's just amazing. So a video that so few people could like and so many people could dislike, and nobody can compose a rational comment explaining what the fuck was wrong with the video. I just don't. I mean, obviously, the audience is insane. Insanely stupid. So anyway, I guess I wanted to show the website, I guess. So that's over here. So the website has all the explanation of the magnetism that's really holding electrons and protons together and causing their repulsion. And all of that is explained by this simple force argument. Some of the technicalities in the gravity argument need to be fixed because they're not exactly correct. But anyway, so the idea of this field of random stuff, and so it's just kind of obvious, okay, that gravity is this just mixed force. So it's proton force, electron force. Doesn't matter whether you think about it being red and black or you think about it being south and north force. It doesn't matter how you think of it. It's just 2 different kinds of things that electrons and protons can tell the difference between the forces. And so gravity, it's just that force not coming at any consistent frequency. Then the electromagnetic spectrum, which has nothing to do with electricity and magnetism, is just that force at a specific period. So there's like bullets from a gun. They're timed. They're coming at a certain regular rate. And then you just get into tipping point arguments where electrons are held in tension, and it takes a certain amount of pressure to tip them over. You could argue, like shooting bullets at a you put a pole on the ground that's easy to knock over, just sitting there balanced. You can know that if you hit it with bullets at certain frequencies, it'll fall over. And if you hit bullets with a different frequency, it won't fall over. And that's all that's happening really with electrons and photons. Photons hitting at certain frequencies pops the electron free because you have enough energy in the right interval to create the right circumstance to tip it, so to speak, to make it wobble and pop. And so that's light, and all the other electromagnetic radiation is just stuff at a frequency. And then magnetism is just segregating that force. That is, all the red force comes out one end, all the black force comes out the other end, all the south or north. And by doing that, it just means that on one side you're compressing the electrons, and the other side you're compressing the protons, and essentially that's moving them. And once you move them, that's called voltage. And voltage comes in the amount of pressure you create. And so it gets kind of obvious. It's just another way of conveying pressure more effectively, is to have the two forces segregated. The force that goes through an electron versus the force that pushes against an electron or reflects off of it. And the same for the proton. So obviously it's a lot easier to push something if you're not pulling it at the same time. So what it basically does, a magnet, is it separates yin from yang. And so it's all yin one way and it's all yang the other way. And that has a huge consequence in terms of creating the imbalance. That is an imbalance in pressure. Okay, I think that's a pretty good statement. Yeah, so maybe we'll stroll over to the Bill Gates video. Really kind of thin pickings here in the subscription box, I have to say. Not much of any value. Veritasium talking about vitamins. I mean, fuck. Jesus. Sorry, but that's too fucked up. Anyway, I mean, how could I care? I mean, I can see somebody caring about vitamins, but not really. If they're interested in physics, they're not really, it's a whole different subject. It really is a whole different subject. All right, let's see if there's anything else I wanted to cover. Let's see, you are too smart for us. Yes, that's quite obvious, unfortunately. It's just really, and I don't know if that's saying anything, right? I mean, oh yeah, I'm smarter than a bucket of slugs. Oh, yeah, I don't know if that's a great thing to say, right? I mean, that doesn't make you feel, oh, I'm smarter than a bucket of slugs. Yeah. Can't feel very good about that. You're just lamenting why are there slugs? Why do we have a universe full of slugs and buckets? It's a stupid thing to do. All right, so Bill Gates again, he's just doing this anal wordplay semantics crap, obsessing about how we define objects and distance and location, and then he gets the motion. And his definition is just, I think, meaningless words. Two or more locations of an object. Obviously, you can't have two locations at the same time. And the idea of motion is the fact that you have to. It takes time to go from one location to another. And even if things could move instantaneously, the motion would be irrelevant as a word if it happened instantaneously. So we wouldn't even bother talking about motion if it happened instantaneously. There would be no conversation about it because the motion would be something other than motion. The change would happen before you knew there was even a change coming or there was going to be a change. So the changes happen at the same time. The non-change, I mean? There's just no transition. Without a transition, there's no consequence. it's like me putting a subliminal message in this video and making it infinitely short in terms of the amount of time it flashes on the screen. That is, it flashes so infinitely infinitesimal amount of time that there's no way it could have an influence on you. It couldn't possibly have an effect because it's as a cause, it doesn't exist. So obviously, so I just don't see how this definition, you can't subtract understanding that time is, because we don't live in an instantaneous universe. Time is a fact, and it has to be connected to what we call motion, because the movement distance has to be captured, and it takes time to capture distance, to change your position, and that's just a fact. So the two are tied together. So again, my definition would be position motion is position change over an update period. That would be the time period. So you're just updating your position, and the shorter amount of time you do that update, the more you'll see in terms of the actual motion. So if you update the universe every 5 minutes, well, then things can jump pretty far in that 5 minutes. But if you update it every 5 trillionth of a second, then nothing can get very far. In 5 trillionth of a second, even a photon is only going to go that far. So you have some hope of seeing what's happening. You'll see it with more resolution. That's all. And obviously, you're going to need a very long life if you're running the film at that high resolution, because not much is going to. There's so much happening. It's going to take you zillions of years of viewing at our slow rate to watch at high resolution. The movie will be going so slow. It's like if this computer screen was playing a movie, or even this video, and you can only see one pixel was updated per second. You can just imagine how many years it would take just to get through 1 second of the video. 1 second of it. So anyway, I don't know if it's worth playing this. I haven't listened to this part. I'm just wondering whether I want to say anything else or just get the hell out of here. I need feedback. I need to have this more interactive. I got to find out why people can't understand. Clearly, you can't understand. I mean, I'm just saying I made it as clear as I could make it. Clear as fucking clear. And in the last video, and 3 likes. I mean, obviously you're not getting it. Obviously you can't, and you're too stupid to even tell me why you can't understand. What don't you understand? I mean, do you understand? I mean, Einstein's theory, I pointed out, Susskind, the one of the most noted teachers of Einstein's mathematics is Leonard Susskind. Well-respected physicist teaching at very highly prestigious California university. And he explains Einstein's field equations by analogizing it to fluid and a drain and like a waterfall that puts the water back in. It's that simple. Okay, that's the 3-dimensional way to understand the bent space picture. So the bent space, when you do it in 3 dimensions, what you're really saying is it's a anti-divergence. So this is the word Susskind uses. He uses the word anti-divergence. So divergence is separating. So obviously an anti-divergence would be a convergence. That is, it's coming together. And that's the pull of Einstein's gravity. Now, why can't you understand that a pull, sucking something out, is just the same as pushing stuff in at the same pressure? So whatever rate I pull it out, if I push it in at exactly that rate, it'll come out the hole at exactly the same speed as I was pulling. It's exactly the same system. So when somebody argues that push gravity is perfectly rational as an explanation, it fits the mathematics, it fits the inverse square. Well, it has to fit all that stuff, because all it is taking their idea of stuff being pulled down into something being pushed in. And it's exactly what actually would happen. So what can't you understand about that? And then when I explained that somehow 300 years ago, they decided to throw this idea in the garbage of push. And for all of this time, nobody has sensed that maybe that was a mistake, that maybe push makes a hell of a lot more sense than creating vacuum cleaners, especially once they discovered the cosmic background radiation, which is a radiation doing exactly what Mach gravity suggests, which is the radiation comes from all directions evenly over time. And you don't get it, that physics might have made a mistake. You can't say those words. Yeah, well, maybe they got it wrong. Yeah, maybe that pull thing was stupid. Come on. All right, so the more mass, the more you block the gravity force bits. You don't block them, you absorb them. You move, okay? The movement is the gravity. The movement of your substance is what's creating pressure that's going down into the earth. You're moving the atoms. The atoms move, your atoms move, your atomic bits move. They move the ground underneath you, creating pressure. So that's where all the pressure comes from. It's because things are moving. They're not blocking. They're absorbing. They're absorbing momentum. Sorry, that's a little excessive, but I mean, yes, the analogies get in the way, right? So, I mean, Susskind has the same problem. Is once you start talking about a bent fabric and then you try to turn it into a convergence, people still want to think in terms of the fabric, and it gets messy. So the shadow thing suggests blocking, but that's only because we don't think about when we're casting a shadow. When light casts a shadow, we're not really recognizing that's what's really happening is this object is in fact moving. The photons cause pressure on it. It feels that pressure, and it actually does absorb that light. And that's why the light doesn't get here. Now, some of it reflects, which is a whole nother concept. So I don't know if I want to get into that argument. Gravity isn't reflecting. It's either absorbed or goes straight through. It doesn't reflect per se. Well, it doesn't really matter, because even if it does, you wouldn't know it. So I don't even want to get into that argument. It would be impossible to see. Even if laser beams actually did bang off of each other, you wouldn't be able to tell. Ironically. Well, you sort of would, because you could shoot blue light at red light, and then you'd be able to tell. But anyway, I don't get into that argument either, because that still doesn't tell you whether the individual tons you'd be able to tell. So the frequency can't reflect, but the actual little bits could reflect. So frequency can't reflect, but the bits themselves can reflect. All right, nobody understand you. It's not about me, okay? There haven't been, first off, I haven't talked to top physicists, so we haven't seen them interact, have we? And doesn't somebody have to explain what they don't understand? I mean, I can say it in Teletubby. I even did this. I said, what? Coco the gorilla. I even used this analogy. I could explain to Coco the gorilla that a clothespin could pinch her finger, and it only hurts while the clothespin is pinching. Just like your motion, okay? You only move while you have captured the force. And when you hit some other force, you might lose what you captured. Gee, that's so fucking complicated. No, it's not. A kindergartner could understand this if he's not programmed to be an asshole. I'm saying I can get any group of high school and down kids to understand exactly what I'm saying, because they wouldn't been brainwashed yet. They wouldn't have an incapacity to do reasoning. And you people apparently do have such an incapacity. I mean, I've given you every piece of evidence you need. I've told you overtly, okay, you can kill me in a public square. You can pull out my guts and let a dog eat them if I'm wrong. Mach gravity is the same fucking math as Einstein's math, just in reverse. It's not magic. It's not substantially different. It's not bizarrely weird. No, it's exactly the same thing, except you're pushing instead of pulling. A tiny difference in a sense, but hugely significant in terms of understanding what energy is, because push is obvious. The energy for push is obvious. This movement goes into this thing. That's obvious. There's no obvious energy with, I am going to pull you now. Pull, 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 pull. There's no obvious energy. Jesus, dumb cunts. Anyway, inside a HARS, gravitation, whatever that is, would be weaker because shield. I mean, obviously, you can't say anything in good enough English here, so fuck that. Soon to be blocked. I'm trying to understand. How could somebody type understand as 2 words? I mean, I don't know how somebody could do that. I mean, even as a fun mistake, I just can't see how that happens. I can see misspelling. I just can't see typing that space bar. Understand. I just can't see that happening. Higher and lower gravity like on moon. Higher and lower gravity like on moon. That's not even a complicated thing to understand. Big thing, small thing. Now, let's say they're made of essentially the same material, which the moon and the earth are, very close. So you don't have to worry about the density of the atoms. But what you're saying is, so they're the filter, like if they were vacuum bags, they're exactly the same amount of hole size in the vacuum. So if they were a coffee filter, it's the same size of holes in the coffee filter. And all you're recognizing is the earth has a diameter this big, the moon has a diameter this big. So what filter is going to block more stuff? The big, thick filter or the little, thin filter? So what's hard to understand? If pushing you, y is less. Wow. So what? This video is only viewable in what? Fuckylvania? I mean, I got 2 fuckylvanials here. You can't even come close to typing English. Oh, shit. Oh, I got to get off the internet. If your theory is right, 1 is right 1. Oh, another Fuckylvanian. If your theory is the right one. Okay, it's not as bad. I'm sorry. I'm start reading badly because of how badly the things were typed. If your theory is the right one, that is, if I have the correct answer, yes. In what sense does that affect our world? Well, it affects it in the substantial way, in the sense is I found the fucking holy grail, the unification theory, the thing Einstein went to his grave not finding, one of the most famous things ever to be done in all of science. So I guess that's sort of significant. And I've found a way where all the forces are related and you can understand them all as a simple checkerboard. That seems pretty significant. Oh man, you are such cunts. You are such cunts. So who knows how it affects the world, shithead? Discovering the round wheel, it takes a little bit of time to figure out, oh yeah, well, I can make a bicycle out of this, or a tricycle. I mean, it takes a while before you figure out, oh, I could put gears on the wheel, or I could make the wheel into a screw. And, it takes time to figure out what the implications would be, you stupid cunt. God, you people are just such pieces of suck. Fuck you, you illiterate. Yeah, fuck you. So we'll just get rid of you. Fucking Fuckylvanians. Never liked Fuckylvanians. Yes, well, it's true. Okay, you can say you were saying that matter over your head would make less particles hit you from above. What matter is over my head? How much matter is in the thickness of the earth going all the way coming out in Fuji? All right, 5,000 miles of earth thickness versus the thickness of my roof. And you're going to make a comparison and say there's some kind of no gravity. No, there is no gravity in the center of the earth. That's already been explained in numerous videos on this channel. So, you know, but the point is clearly there was no there was no sentence structure that could possibly make it known what the fuck that question could mean. Oh, okay. So Lukoa said exactly what I just said, pretty much. So the more mass, the more gravity force. Clearly, mass gets into a tricky word, but yes, of course, the more atomic mass in a certain amount of space. So when they do something like a galactic cluster, you have to recognize that, oh, galactic clusters have a lot of empty space in them. So the density is very, very light. So yeah, you have to take the total amount of atoms in the total amount of space. So it's a density argument. The density of the object will dictate how strong the gravity is on what you might call its surface. And as I've sort of pointed out, surface is a little ambiguous. Nothing has a hard surface, technically. A completely solid surface. Atoms certainly don't. Yes, and more about absorbing than reflecting. You don't need to bother with reflections when it comes to gravity. They either go through or they hit. So they're either absorbed, that is, there's no, the gravity hits and bounces back, so to speak. That doesn't happen. So it either hits and is moved with the object, or it misses. But those are the only two options. The rational science guy comes off as arrogant. You know, everybody comes off as arrogant, Alex. You come off as pretty arrogant. So, if I give away arrogant awards, we're all going to win. So, no point in bothering with that. What he comes off as is he's just kind of douchebaggery in the sense that he's again arguing with dead people, arguing with Aristotle, Plato, all of this kind of crap, when there's alive people right here in the universe that he won't argue with. So that's the part that's kind of weird. Why do these people always pick on dead people to argue with? Why don't they pick on some living people? Now I understand why you get pissed at people, always having to re-explain the basics of your theory. Yeah, well, I'm just saying that if people don't understand, why can't they form a question and say, okay, I don't get how push is simpler. How push is simpler than pull. So just, okay, if you don't understand how it's not profoundly simpler as a mechanism, I mean, this moves, hits this moves. I mean, that, that it's not obvious and intrinsic. It's like a fundamental thing. You can understand it fundamentally, where you can't understand pull fundamentally. There's the only way you can understand. Like I said, I would argue that pull, you could understand it as this thing snuck over here, push this thing, then snuck back over here. And that's push. I mean, that's pull, right? I'll push you to make a pull. But it's really hard to come up with a pull mechanism just holding two things and saying, now make pull. You can't do it. But if you say now make push, all I have to do is say this thing is moving the speed of light and it hits this thing and now this thing moves. That's easy. So it differs. So it differs from photons. So it differs from photons. How many times have I said over and over again? All the forces are the same exact thing. They're all made of a little bit moving the speed of light. Just a little round thing, square thing, triangle thing, doesn't matter. A thing moving the speed of light. Gravity is a thing moving the speed of light. Photons are a thing moving the speed of light. Magnetism is stuff moving the, things moving the speed of light. And the only difference is gravity is mixed and not at a frequency. None of it comes at a steady frequency. Light, or the electromagnetic spectrum, the things come at very specific distance, rigidly specific distances. The bullets are fired exactly 1 second apart, or exactly 1/2 second apart. Okay, that's the electromagnetic spectrum. Things at a frequency, a specific frequency that they're shot at. Okay, and then the third variation is there's two kinds of force, black and red little bits, two little things moving the speed of light, and they're all mixed up in gravity. And then magnets filter the two things, and all the red ones go out this way, and all the black ones go out this way, and the red and the black affect electrons and protons inversely. And that creates high and low pressure, which creates the possibility for things to move into each other. See, the black force reflects off black things. So if this was black and black, the little bits would bounce back and forth here really fast. So the closer I brought them together, the more pressure created. But black force flies out perpendicularly from reds. So all the black force is flying out perpendicularly. All the red force is flying out perpendicularly. All the force disappears. That's why the magnets move into each other when they're inverted. All right, the particle has energy, momentum. Either it encounters another particle with mass and gives 100% of its kinetic energy. That is, it's absorbed. That's the trap argument. I mean, I drew it yesterday. It's absorbed. The energy is absorbed in a trap. The trap can either be back and forth trap or it can be a circular trap. But the point is the energy comes in and the energy doesn't get out. So the little ball bearing goes in and it just keeps going around and around and around. So the photon comes in and the energy just keeps going around and around and around. 4 right turns, whatever way you want to metaphor it. And until it's let loose, until it gets out, this thing will start to move. So the movement is absorbed. That's why gravity creates movement. Is actually the movement is before the shadow. Get it? Before you can cast a shadow, you have to absorb the thing. So you have to move before you can actually create the shadow. So gravity is more about not blocking something, but again, absorbing motion. And obviously the motion of the big thing, right? The light is moving the speed of light. The gravity is moving the speed of light, but it's tiny. The Earth is a big, huge thing. So the Earth, when one little thing moving the speed of light hits it, you have to calculate that one bit of speed of light motion over the entire mass of the Earth. So the Earth moves only a little tiny amount. So it's just that the big things move so slow, but they're just really doing the same motion that the little photons would do, but clearly they've absorbed them and slowed them down, essentially. I don't know how to say that. They haven't slowed them down. They are spreading their motion over a big, huge thing that isn't moving. And so it's obviously the amount of distance you can travel reduces the more crap you put in your car, right? You make your car heavier and heavier and heavier. The amount of speed you can go gets slower and slower and slower. All right, let's see. With mass and gives 100% of its kinetic energy. Either it doesn't encounter anything and it just goes straight. Yes, either absorbed or not absorbed. So because it's all the same thing is the reason why you don't want to give a name to those particles. Well, that's the trick. I could call them gravitons, but is that really saying what they are? Because they're really chargatons, right? I could call them chargatons because they're really black and red. They're really two kinds of force, you know. So if I call it gravitons, I'm implying it's all the same stuff when it's really not. Because for magnetism and charge, there has to be the difference. The difference matters, and it's so significant. So I want to call them magnetons. You know, I can call them chargatons, magnetons, blah, 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 blah. I'd rather just call it force. And I'd rather say all force moves the speed of light, and you can change the force either by segregating it for its shape or moving it at a specific frequency. Can the trapped energy ever be released? Well, of course it can. I mean, just like you could release the moon, so to speak, by giving it a little hit. So obviously another photon could come in, hit the moon at just the right location, you know, two little bullets hit it just at the right speed and pull the moon right out of our orbit. Well, I guess I just explained that for you. If so, what would trigger that? More energy would trigger it. I say differs because protons reflect and gravity doesn't. I'm not really interested in what you say. I'm defending my theory, so I'm not at all concerned. As I stated before, reflection is built into the absorption. So I don't really want to have to keep explaining this kind of stuff, but you know, two things go in and two things leave, technically. And what you're really counting on is this color difference. So frankly, what's really happening is something of one color is hitting something of another color and changing its direction. So if these two things were black, you couldn't see this interaction. It would be invisible to you because whether they hit or whether they miss, the universe would look exactly the same. Black would be going this way and black would be going that way. And it's only because of this color difference that you can see the difference. So that's all reflections. But again, if you get into that detail, then you really just can't do gravity simple, because then you have to explain gravity as a magnetic effect, okay? Because gravity is really part of it's part of the charge phenomenon in a sense. It's just that it's just an unnecessary amount of detail that you have to go into, because the bottom line is this is an absorption of momentum. This thing was going this way. Now this thing is going this way. That's the idea. This thing was going this way. This thing's going this way. The idea is this motion is now this thing's motion. That's what I mean by absorption. All right. Say there's a different cause. Photons reflect, the gravity doesn't. Well, I'm not going to bother with that. Me trying to be a nerd. I don't know what that means. Not helpful. Don't type. Or you may never be able to type again here. Where's the data for this, Mr. Mathis? Oh, this is just hilarious. Anyway, silly persons. Oh, you're so funny. What a funny joke. As I just pointed out, the math is identical to Einstein's math, except you just change the signs, okay, from plus to minus in terms of whether you're pulling things out of a drain or whether you're pushing things into a balloon. So fuck you. Okay, would there be any way to qualify how many parti, can't, particles, okay, somehow you hit enter in the middle of the word, are going through a defined area of space at a given moment? Yes, there's a certain density to the force of gravity. That's sort of what I'm arguing. And it's probably detectable in the sense that if we could find the heaviest object in the universe, we could probably dissect some information about the density of that gravity. But I would argue that the pressure inside the protons, inside the atom, that pressure, the strong force, is essentially a definition of the strength of gravity. It's the inverse reciprocal consequence of the density of the external pressure. The gravity pressure is essentially holding the atoms together. Obviously, it's in the form of magnetism, but I'm just saying it's still just the pressure of the external pressure that's holding the atom together. So, yes, there's a way of doing it. I can't, not, you know, I don't think I have the math skills to do it, but it would be, I think, fairly easy to do. There's clearly a defined amount of pressure. There's no arbitrary amount. So the external pressure is one thing. It's like 1,000 pounds per square zekimeter, whatever you want to call it. You know, tiny little thing. But anyway, so we'll just say it's a certain amount, and it doesn't get any more. And so all you can do is create an object of a certain size that collects this momentum. And we know that collecting momentum means you're creating pressure. That's why the Earth's core is molten. So it essentially creates heat. And the same thing is pressure in some ways. It's exactly the same thing in a lot of ways. Heat is pressure. And so obviously there's a certain point where if you create all this heat, you can imagine that that amount of harassment of an atom is going to break atoms, or they're going to melt into something else, or they're going to be transformed. So heat and pressure is associated with alchemy, with transferring or changing how atoms function. And I'd certainly argue that the hotter the pressure, the higher the pressure, that means the more energy that was converted. You got to remember that gravity is being converted. So the gravity hits atoms. The atoms smash into each other and create the pressure. So the photonic pressure is converted into chemical pressure. So you kind of have to understand that. But the photonic pressure clearly stops being felt in the center of the Earth. There is no photonic pressure in the very center of the Earth. And the only thing there is the chemical pressure. But the chemical pressure, you have to understand. See, it does get, I mean, it is physics. So there's lots of little things to understand. You have to understand that the chemical pressure is essentially the same in some respects as the photonic pressure. So you have this pressure from the outside, you know, between atoms coming in. This is a really bad drawing, but it'll do. All right, so you have two little things next to each other. And as you push them together, this energy is still made out of photons, these little bits caught between them. So the closer they get, the higher this reflection rate happens. So this pressure from the outside comes in. It pushes things together, which creates pressure between the photons that exist inside the chemistry. So essentially, you convert the gravity into reflective pressure between the atoms. And so that takes the place of the gravity in terms of holding the atoms together. But you have to understand it's a different way of holding an atom together than the gravity. Sort of different. And that's why it's unstable. And that's why things explode. All right. There's a link between the speed of that force. Now, all the forces are the same, so I don't even play with this stupid speed word. It's irrelevant. And the fact that matter can't go faster than light, but I can't pinpoint it. Well, clearly, it can't go faster than light because it's the school of fish argument. Essentially, the matter is made of a bunch of bits already moving the speed of light. And if they're moving the speed of light in this circle, right, in the trap, right, well, that trap has stuff going this way, and exactly the wrong way, right? You know, well, exactly the wrong way from which way you're going. So obviously, if you took matter and tried to move at the speed of light, there's a bunch of pieces of the matter that can't possibly be going the speed of light. So if you have fish in the school of fish, they're going this way, and you're trying to move the school of fish this way at the speed of light, clearly the fish going this way can't play anymore. They can't be part of the school. So unless you turn them to be going the right direction, you can't go the speed of light because you have shit going the wrong way. And once you get them all going the right way, well, then you essentially have light again. Now you're back to a force. You've converted the matter into a force. Once you have all the fish moving the same way, it's not a school of fish anymore. It's a beam of fish. You know, it's something else. It's not matter because it doesn't have dimensionality in any other direction. There's no fish going horizontally anymore. That means you have no pressure going horizontal. That means you don't exist going horizontal. There's nothing for anything to hit on the horizontal plane. You don't exist. You have no material substance. Just like a photon. A photon has material substance only in the direction it's going. In every other dimension, it's invisible. It doesn't exist. It has no reality. It only exists in the dimension it's going. It's a one-dimensional object versus matter, which is a three-dimensional object. So to make matter, a three-dimensional object, travel the speed of light, you have to convert it into a one-dimensional object. Oh, there, that's so obvious. Did anybody miss that? I mean, that's really easy to get, right? Photon, one-dimensional object. It doesn't do anything going this way and this way or this way and this way. It's only doing something going this way and this way, right, into the camera. It doesn't do anything this way, and it doesn't do anything this way. It only does stuff this way. So it's a one-dimensional object. Matter has stuff going in all dimensions, all directions. So to make matter go as fast as light, you just have to get rid of those other two dimensionals. You have to bend them the right direction. All right. There's a link between the speed of that force and the fact that matter can't go faster than the speed of light, but I can't pinpoint it. Well, I already pinpointed it for you. Correct me if I'm wrong, which you probably are. I heard that black hole, well, I hate the word, has highest degree of gravity. It may attract the light passing in front of it, passing through it. Is that true? Obviously, I think that's absolute horseshit. If you just even give it a little tiny bit of thought, this whole idea that the gravity has special properties here with light, so it can bend light. You know, here's a sun. It can bend the light somehow. It moves, you know, because this way, somehow it can move this way horizontally. But if I put the sun in front of it, I can't make the light go any faster. But some physicists actually argue that if I shoot the light off the surface of the sun, somehow the gravity will bend it. So somehow it'll move slower, somehow, you know, by some weird magic. So clearly it's just horseshit. No, you can't move photons. Photons only change their direction when they hit an electron. That's it. Or a proton. That's it. They don't hit one of those two things. They're going straight. And by electron and proton, I also mean neutron, of course, because a neutron is an electron and a proton. So, you know, I don't want to get into all the details. It has to hit a matter bit. Photon has to hit a matter bit to change its direction. That's it. There's no bending one. There's no influencing one with gravity. It's just nonsense. All right, L-E, T-he. I don't know what T-he means. I don't know, you got a typing problem here, buddy. T-E-H. What are you doing? Stop doing that. It's just confusing me. So the force bits are extremely small monopoles. Yes, the monopoles of charge and magnetism. That's right. The proton and the electron are the magnetic monopoles. They define magnetism. Oh, I shouldn't have said the force bits are monopoles. No, they are not monopoles. The electron and proton are the monopoles. The force bits are the things the monopoles are filtering. The force bits have they emit no field energy. Okay, they can't absorb stuff and change it. Okay, an electron has stuff, so a black thing can come in and a red thing can come out. The little bits don't have any properties like that. They can't be radiating red and black bits. They don't have any force field around them. They are the bits themselves. They are red or black. They are not anything else. They're just a thing moving the speed of light, and they're one quanta, one red bit, one black bit. That's all they are. They have no fields. They emit no energy. They either hit something or they don't hit something, period. The monopoles are the electron and the proton. All right, so let's see. Playing devil's advocate. Well, I'm not terribly interested in that, but anyway, they don't claim gravity bends light. Yes, they do, but fuck you. Let's see what he says. They claim it bends the space light travels in. It doesn't matter. The point is that there's no reason to think light doesn't leave perpendicular from a surface. And if it leaves directly perpendicular, it can't be bent any one direction. So its escape velocity should not create any problem. Now, they might argue that light that leaves not perpendicular from a gravitational source would be bent. But again, it's this argument that somehow you can bend light moving this way, but you can't accelerate light or make it move slower. So isn't that convenient? And again, I'll just argue there's absolutely no hard evidence that a photon has ever been bent by gravity or magnetism or electricity. It's just nonsense. Light doesn't bend. It diffracts. It is consumed by electrons and protons and readmitted at angles. There is no bending. Let's see. And again, you have to understand that this, you can't keep using this analogy of this bent gravity thing, because again, it's a convergence by Susskind, an anti-divergence. So again, you have to recognize that that divergence is the metaphor to a fluid, and so something is bending the light. It's not some geometry thing. It has to be turned into some kind of ether or field or some kind of mechanism that somehow is changing and forcing the light to move in this new direction. But it has to be a something, not a nothing. And clearly, they're just running from the ether they're creating. They're creating an ether and they're just running from it by pretending it's geometry instead of ether. No, it's ether. They're making a medium. Push, pull, parallels. Where's the parallels? I don't know. Push, pull, parallels, paradigm is key. How can I make sense out of that? Push, pull, parallels, paradigm is key to my PAS reality. I don't know what the fuck that could mean. A shitty joke, that's all I'll say. I mean, if that's supposed to be a joke, it's just not even close to funny. Yeah, I didn't get it. Totally right over my head. You say you tell me how microwave works. I'm not really doing microwave ovens. I'm just explaining gravity at the moment. That's what the video is titled. But I mean, microwaves are just a certain frequency of radiation, and that frequency happens to jiggle the electrons in water really well. So the electrons in water are at a certain pressure. They're like a certain weight of post. So if there's like a heavy post or a light post, it takes a different speed of bullet to knock it over or to cause it to tip. And so microwaves just happen to be really good at vibrating water molecules because they're in just the right tension where you can get them wobbling like crazy with microwaves. So the bullet speed is just right for the tension of the electrons in water. You not tell me you lie. So I don't know what that means. So Fred. Fried. Oh, fried seaside. I don't know what that means. Kentucky. Anyway, you're almost blocked. So say something else stupid and you're blocked. Thank you. Well, I'll let you get away with that, but that's pretty close to stupid. Thank you. Jeez. I mean, what's your real name? Bubba? They kind of make an Ether claim. That's right. After all, if they say space can bend, something has to bend. Well, like again, it said they're not really saying it's bent space. They're saying it's moving space. It's moving towards the center of the every material bit is consuming space. The space is converging into it. Everything has a little vacuum cleaner in it. The proton and electrons are clusters. No, whatever. Says you. I don't agree. Of them, or admit them only on impact. Again, it's ping pong paddles. Things get trapped between things. Two electrons. Black bits get stuck. They just go back and forth, back and forth, back and forth. Electrons are far apart, low pressure, not too many impacts. They get close together, lots of impacts, lots of force, lots of energy. Not much more complicated than that. I mean, obviously you have two ping pong paddles, and you have two ping pong paddles, electrons. And you have stuff moving back and forth, trapped between them, bouncing back and forth, back and forth, back and forth. If I move the electrons, you could kind of see that some of those ping pong balls would escape. That's the creation of a photon. When the ping pong balls escape, that's the photon. See, if the electrons are really close together, then when the ping pong ball escapes, it'll be X-rays. If the electrons are further apart, then it might be ultraviolet light. If they're further apart, then it might be red light. Slow frequencies, you see? Slow frequency versus very fast frequency. Clusters of them, emit them only on impacts. I think I answered that. So basically, since they say they have mass, they are literally claiming they suck space. Yes. That's what they're claiming. And that somehow the Earth knows, hey, there's missing nothing next to me. There's double nothing. I better move into the double nothing. It really is that stupid. Somehow the nothing has disappeared. I must move into the empty nothing, double nothing spot. So you really have to, I'm just saying that's their metaphor. That's their analogy. That's the best they can do to describe this stupid thing. And I guess I'm just pointing out how, wouldn't it be just simpler to say this stuff is just being pushed? The push is easy. Again, the pull is impossible to create. The pull is complicated. I can't make a pull out of these two things and say, move one of them to create pull. Oh, I can't. I need something else. So they're dead. I mean, it's a dead. Again, they can't make it make sense. That's why he says things as silly as anti-divergence for the word convergence, because he knows if I say convergence, that's going to sound like a vacuum cleaner. I don't want people to keep thinking about vacuum cleaners, but yes, that's exactly what they're describing. Well, Danish physicists, you really haven't been watching many of these videos. I mean, the last 3 videos have been on the subject of Lesage gravity, so you obviously haven't watched any of those. So I don't know what to say to you. But obviously it was not inspired. This whole thing never happened because of Lesage gravity. I found out about that after I had already proposed particle gravity. And then somebody pointed out, hey, a guy 300 years ago already thought of it, so you're an asshole. And then so I had to look it up, and I found out, oh, yeah, it's the same thing, but it's different. And I explained why mine's different. Obviously, I know atoms exist, and I know electrons and protons exist. Lesage didn't. So obviously, I can fix a lot of Lesage's problems. But it's obviously, you can call it Lesage. You can call it Fadio is the real guy. So again, even saying Lesage is insulting Fadio because he's the guy who originally proposed it to Newton. I mean, Isaac Newton signed the paper Fadio submitted to him. Newton liked the idea. So let's not pretend this is some sort of goofball idea. And now in modern physics, it's called Mach gravity. So they don't call it Fadio, they don't call it Lesage, they call it Mach gravity. And it works perfect for gravity. What's the difference between a photon, spelled with an F, and a graviton? So again, I haven't used either one of those words as a thing, so why should I have to explain them? There is no graviton. Conventional physics has a theory of something like a graviton, which is a virtual photon. It's like the virtual photon for magnetism, but it doesn't have any definition because obviously you can't create attraction. Okay, again, they keep trying to make attraction. So if I give these two pens and I say, you have a baseball you can throw at the other guy, called a graviton, how could that possibly create pull? How could that work? It can't work. You know, unless you say you can throw it this way and it'll curl around and hit this guy in the ass. But there's no other way for it to work. So graviton is kind of a bullshit word. I like I said, I don't have any interest in using it. I mean, until everybody agrees that we're going to create language that we can communicate with, I don't want to use it. I'm perfectly comfortable with the idea that if you want to call gravity gravitons, and you want to call photons photons, and you want to call magnetons magnetons, that's okay with me. But as long as you understand they're all made of the same thing, it's all one force. There's not four forces. They're not three different forces. It's all one force, and it's doing one thing. And the only thing that changes is when it hits you going this way, like there's red, black, red, black, red, black. It can hit you that way. You'll feel it like gravity. And then when it goes through you, it comes out all reds here and all blacks here. That doesn't affect you any. You just got affected by the mixed force. But you're creating a consequence that will affect somebody else very different. So that's all. As long as you understand that it's the same exact force, it's just changing the configuration of the bits, changing how they're arranged. But it's all the same bits, the same amount of bits. There's no gravity and magnetism. The gravity goes into the magnet and it comes out magnetism. It's the gravity that's converted into the magnetism. It's the same force. I don't know why people would type Japanese in here, whatever the fuck that is. What a silly thing to do. I mean, I just don't understand why people do that. What purpose does that serve? You think there's somebody in this room that speaks whatever that crap is? Jeez. No, there's nobody in this room that speaks that shit. Go back. See, what is the difference between a photon and a graviton? Well, now I think I've explained that 7 million times. Photons have a frequency, kind of obviously. Gravitons, no frequency, obviously. Magnetons, segregated force, no frequency. They're just different versions of the same thing. So a bit that is trapped by an electron is the one we see. The one trapped by a photon. What the fuck? Nothing's trapped by a photon. Oh, proton, sorry. Ooh, my mistake. No. Protons don't do shit. They're stuck in the nucleus. So they're just not really players. The electrons do the photon thing. So it's only the black force that comes at a frequency. There is no electromagnetic spectrum for protons. Gravity is a completely different, because gravity is affecting every single little bit that's matter anywhere, and it's giving it nudges. And the nudges create reflections. So if you have a proton here, and a proton here, and a proton here, and a proton here, and we know that the electron force, the black force, goes out of the proton perpendicularly, you can get the idea that, oh yeah, the black force is going to take a right turn, and then it's going to take a right turn, and then it's going to take a right turn, and then it's going to take a right turn, and then it's going to take a right turn. And it's going to take, you can understand how it could get trapped, how traps can be created by combinations of the black and red things, that is the electrons and the protons. It changes the path of the little bits of energy. but gravity is trapped and light can be trapped. But I'm just saying the gravity is light. I can put gravity into a system technically, and I can make photons come out. So the pressure, let's say that the Earth is being forced into, all this pressure from gravity. So the pressure of the gravity is crushing the matter in the Earth. It gets hot and it releases photons. Those photons technically came from the pressure created by gravity, and they're not going to be that the Earth loses mass to create them. So the infrared radiation that's leaving the Earth, let's say, is not necessarily radiation that wasn't created by gravity. That wasn't part of the mass of the Earth. It's a consequence of the amount of force the Earth has collected in the form of gravity, and it's converted the gravity into photons. The matter can convert the energy. Okay, so the force is the energy, let's say. Or let's just say the matter can convert the force into any one of these things. It can convert photons into gravity. It can convert magnetism into photons. It can convert the force at any time at will. Gravity can come in, photons come out. Photons can go in, magnetism can come out. Any kind of arrangement is possible. It's just one force. Again, I don't know how to keep saying that. It's just one force, just slight variations. It's an El Dorado. It's a car. That's this. One's red, one's black, one's green. There's subtle differences, but they're not profound differences. I mean, it's not that hard to understand. Let's say I have just black and red soldiers, a big field of black and red soldiers. I can say just the black soldiers, and I want you all to line up, one arm's length away from each other, and then move to your left. So I've just converted all the black soldiers into light, moving in a direction. Okay, that easy. Now I could say all the mixed soldiers. I could say, okay, no, we're not doing light now. We're doing magnetism. So all the blacks go take a step to your left. 5 steps to your left. All the reds take 5 steps to your right, and I can come up with some mechanism that makes that eventually gets all the blacks on one side and all the reds on the other side. And then I tell them, reds guys go left, black guys go right, and now I've created magnetism. You see, it's all one force. It's just how you decide to deploy the soldiers. You can deploy them as photons, visible light. You can deploy them as X-rays. You can deploy them as magnetism. You can deploy them in these different ways. All right, frequency, good answer. Yes, that's the difference between the graviton and the photon. So, but it's also has to do, like I say, that technically the electromagnetic spectrum only affects the electrons. It's an electron force. It's black energy, whatever you want to say. It's electron energy. Frequency. So the bit that is trapped by an electron is one we see. The one trapped by the photon is gravity. So the bit, so you're using you're using 2 different words. You're calling a photon 1 minute and a bit another time. I don't know. So the bit that is trapped by electron, between electrons, it's not trapped by the electron. The electron can't eat the bit. The electron reflects the bit. So again, ping pong paddles. 2 electrons are like ping pong paddles, and there's a ball between them. The closer I bring the paddles, the faster the ball bounces if the ball has a constant speed. And the more pressure between the paddles. You can sort of understand that means more pressure. The faster the hit rate, the hits are the energy. So the faster the hit rate, the more energy, the more pressure. And the further away they are, the more relaxed it are. Bing, bong, no problem. All right? Can you understand that? is the one we see, the one trapped by the proton is gravity. You're saying the same thing you did before. No. Oh, I must be way back. Yeah, that's why that's the same. Okay, I get it. All right. Sorry. Not entirely your fault. Yeah, crystal do it to pressure you get light. There's no crystal talk here. It's just no crystal talk. Fuck that shit. Oh, man, I don't know. You people just suck. My phone is about to die. We'll finish the stream later. Yes, okay. Good luck with that and such. I don't know how much further I'm going to go. Obviously, there isn't much here on the subject. You know, start getting into crystal talk and shit. I should have just played the Bill Gates video. Well, anyway, it's quite obvious. I'll play some of it. What the hell? But it's just all this semantics about, you know, figuring out what motion is. And I just think, yeah, motion's just kind of obvious. And what we're talking about is resolution, how closely you're looking at the motion, you know, the time scale and the depth of your resolution. But we know what motion is. It's change in position. That's what motion is. And we know in our universe, because there is no instantaneous, that change in position takes time. It has to move through all bunch of positions to get to the new position. Each one of them are real positions by a Planck constant of resolution. Just not that complicated.
That's the point. If you're going to use adjectives only applied to objects, what is an object that we just shaped? You can say that the table is red. You can say the table is continuous. You can use it in that sense. Likewise, if you're referring to something that has motion, to some dynamic concept like information. Information is a dynamic concept, I think, right? Because it's like a flow of information, I guess. Maybe you can even say that. Well,
you know, information is obviously, in my opinion, not a dynamic concept because it can be stored in a book that sits in a library and isn't doing anything. It's just a collection of information.
But it's really how you use the book.
Well, again, you have to know what you're referring to. If you're referring to orbit, you know it's under all circumstances, the word orbit is a verb. Now, they've turned orbit into orbital. You know, the orbital, the energy levels, you know, orbital of an atom. And they turned this verb into a noun. They turned...
I don't think they really have, so I think that's sort of horseshit. That's just, again, it's just kind of semantics. It just doesn't really go anywhere. So I don't think I'll waste time on this because yeah, it's just a waste of time. Semantic nonsense. Wouldn't the black bits lose kinetic? Oh shit! Your brain just wonders how the fuck can people keep doing this shit. Obviously, the photons, I'm arguing, have constant speed. They always move the same speed. They never slow down. They never stop. They can't be slowed down. They can't be stopped. They can't in any way ever be anything. Well, they are a full photon moving the speed of light. So obviously, a photon can travel 15 billion light years from the end of the universe, and it will get here at the right time because it's a constant speed. And if it hits something and it goes this way and it goes this way and it's this way and this way, it won't lose any speed. Nothing, I mean, shit, nothing goes through some medium even when light goes through a medium. I mean, the obvious answer is it takes a longer path, like a fiber optic cable. It bounces crooked. That's why it takes longer to get through it. But even if you think the photon slows down when it goes through glass, it obviously comes out of the glass the right speed. Shithead. I didn't know you were such an asshole, Danish guy. Yeah. Wouldn't the black bits lose kinetic energy? Okay, now I'll read the rest of the sentence. When it pushes the electron. No, it's obviously 100% kinetic ball frictionless interaction. Two things go in, two things go out, same speed in, same speed out. Nothing fucking goddamn lost. No little bits fly off photons. They don't get tired. They don't go around things. They don't half hit things. They hit it kinetically. Purely kinetic, no losses, conservation of energy. Energy, movement in, movement out. Mass in, mass out. No losses. The photon doesn't break into peditons or biditons or whatever. It doesn't capitons. The photons don't fall apart, for fuck's sake. Could a laser beam move a little? Well, of course it can. They can move a big object now. You can move shit with lasers. Yes, no problem. People have already done it. Not complicated. Light is force, but it does give you some appreciation for how much force the gravity must be. I mean, obviously this is huge. This velocity is huge if you had to make it happen this way with a laser beam. If I had to push this pen with a laser beam, you'd be like, oh, it's going to take 10 million billion zigwatts of energy to move that. So it does give you some appreciation for how strong the pressure must be, that this pen can gain so much momentum compared to what a laser does. Light is an incredibly weak manifestation of the force. That's why magnets seem so strong. It's because, yeah, the force is strong. Light's a feeble representation. A tiny percentage of the universe's energy is in the form of visible light. Okay. Piezoelectrics and triboluminescent science, or whatever that crap is. I don't know what this little bullshit. Nuclear equals nuclear equals nuclear. That's really cute, but do it again and I'll block you. I'll just remove it this time, that little queer shit. But we don't do that here. We don't do jokey little haha fun stuff. I hate fun shit. Trivial puke. I hate people. I just hate people. Hate you, I hate you, I hate you, I hate you. Wish to travel to the, the single, it's a way to say it, the great anti-convergence. Yeah. I have to get as far away from this universe as possible. I'd like to anti-converge from this universe. Fucking rain. It just keeps raining here. Ugh, it's disgusting. Life doesn't last long. I guess you haven't been alive very long. Been here a while, you'll start to feel how long it is. It's going to start feeling very long. But if the bit maintains its original speed, where does the additional... Oh, fuck you. There's no additional kinetic energy. Again, I just don't know how you can't understand. It reflects. And it's just about changing what's moving. All energy, there would be nothing, and you couldn't see anything happen in the universe if it was just everything was black and the little bits hit and they reflected, because you couldn't see the difference between hitting and missing. So all you're really talking about is when things hit and they're different, then you can see that this happened, or you can see that some other thing happened. There's a difference. They say two things come in this way. You can see because this thing's not doing this. This is what it was doing, red going this way and black going this way. And now it's red going this way and black going that way. And that's a huge change. So again, I can't tell you, I mean, I've been over it and over it, that the kinetic energy is stored in a loop. So just think about it, Danish physicist, all right? You're a physicist, right? So if you understand, if this is a box and it has a loop in it, and I can have a switch here that opens the loop so the ball can get out, or it closes the loop so the ball just keeps going around. And it's all frictionless. And I throw a ball bearing into that box, and it goes into the loop. I have it, I'm in the opposite direction of the arrow. I throw it into the loop, okay? And it loops. The box will move. And then if I flow the switch to let the ball out, then the box will stop. So the box captured the motion, moved with it, and then when you let it out, you stop. That's simple. And it happens because the initial movement forward is always repeated. That one's never compensated for. So yes, you have up, down, it's all conservation, but the only thing that isn't conserved is that initial forward motion. That's the one that's never conserved. That's outside of the conservation of the circle. The first move is always outside the conservation of the circle. All right, but if the bit maintains its original speed, where does the additional kinetic energy of the electron come from? So again, I'm just not doing that. Am I unblocked? Yes, you're unblocked, cunthead. I had to actually go to your fucking channel because my block list didn't have your stupid cunt name in it. So I go through this whole fucking block list, 4,000 names in a stupid block list to find your stupid cunt name. So I wasted like 12 minutes looking for your stupid cunt name. And then I finally figured out, oh, if I go to his channel, maybe I can unblock him there. But yes, you wasted 12 minutes of my life. So you better not fuck up. Danish physicist, the thing you have to understand is the electrons are three-dimensional objects. Okay, they have stuff moving in all. They have pressure in all three dimensions. They have a surface in all dimensions. That means they have stuff that's always going this way, so to speak, going this way, going this way, going this way, and that stuff is just stuff comes in. It gets bent in a new direction, blah, 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 blah. So it's all just pressure that comes from the outside that they just release as their pressure, their substance. And it's three-dimensional. So when something comes in, what's really happening is you're exchanging a bit going this way for a bit going this way. So you've turned this one this way, and you've turned this that way. But the important fact is you flip this way. And so that's why you have the extra amount of energy this way, is that you converted something going this way into something going that way. That's a way you can understand this. Nothing hits an electron, so to speak. The electron isn't an electron. An electron is a bunch of pressure itself. And you're hitting the pressure of the electron, the bits of the electron. So there's like bits of photon inside the electron. If you, I really don't want to get into that depth. I'm just saying that for the purpose of the argument, just to understand it as being purely kinetic. And so there's no losses. You absorb something. So again, if it's the ball bearing hitting a cue ball, the idea is the ball bearing doesn't bounce off. The idea is it goes into the cue ball and stays in there. And then you release it. So the momentum is consumed. And I'm saying it's consumed by the circular path as a way of consuming it. You're consuming the momentum. And the angle of that momentum is conserved in the system. So whatever way it first came in, is the way that's the real momentum you ate. You can give away momentum this way. You can give away momentum this way. but the momentum you gained was in this direction, and you're going to keep going that way until you give away that, till you give away the stuff you ate. So if you go this way, you've only lost part of the momentum going this way, if you get my drift. So you could let something, I could absorb something going this way, and I could let it go this way. Well, this way is only a portion of that forward momentum. So I still have a percentage of that forward momentum, if you get me. And what I really gave away was momentum this way. So now I'll end up moving that way. See, so if I convert this into this, I'll have to give away this as direction. So the electron, if it gives it away this way, it'll start moving this way and that way. So it'll move this way. Get it? You can always convert it into just these kind of interactions. You can always turn it into a simple Feynman diagram, so to speak, just to get the angular change. But there's no friction in the system. So the angular momentum is always conserved. And you're gaining the force in one angular momentum. So when the space shuttle takes off, the angular momentum being eaten, that is the ball bearings being consumed by the person sitting in the shuttle, he's collecting a bunch of energy with specific angular momentum. All right. And he can hit the ejector seat, but if he hits the ejector seat, he's still going to be going this way. You know, he's going to come out this way. You know what I mean? So his angular momentum is going to be a reflection that hitting the ejector seat doesn't remove all of your momentum. It just changes your momentum. Okay. Ha. You got a belly chuckle out of me with your answer to Ash. Oh, yes. Well, I don't know if it's worth that much chuckle. How long can hard objects get thrown fly? Jesus. I don't know. How long? I mean, really, what is it? Is the internet only works in what? Hole in your head, Nebraska or something? What the fuck? Where do you people come from? How long can hard object get thrown fly? Ah, fuck. Oh, who cares about solar power? I mean, Ash, you're already in trouble. I don't really want to do. Oh, did you hear about the super special silly science news? No, I didn't hear it. Because I don't waste my time listening to stupid stories about trivial shit. I'm full free energy car. Did you hear about the solar powered car that is going to be on sale in 2019? Oh, how very exciting. The hood, roof, and trunk are an entire solar panel. Who cares? You can't go anywhere on solar energy. I mean, I can put a 300-watt solar panel in my yard and spend $500, and I could get all the energy it makes, and I could run a battery that carries me for about 18 seconds. I don't know how efficient it is, though. Yes, it can't be efficient. Solar energy is incredibly weak energy. I mean, it just isn't that much solar energy. I mean, it's only 1,000 watts per square meter. That's if you got every single bit of it. I mean, and 1,000 watts won't even carry you very far. You know, 1,000 watts. If you collected 1,000 watts for an hour, you could barely move you 4 miles an hour. Barely. Oh, shit. So don't do this, Ash. Just don't. I mean, I warn you. You just keep doing this off-subject crap. If I understand you correctly, you're using the idea of momentum as a vector. Well, certainly it's a vector. Undoubtedly, all the force bits move in dead straight lines. When they hit something like an electron or proton, they also they give it a vector in a straight line. But as I just pointed out, the electron has other agendae. It's already wobbling in space. The electron's doing this. It's all wobbly. So when you hit it with a vector, the motion you'll get out is going to have a little bit of that wobble in it. So you're not going to get a pure reaction from the wobbling electron. You're going to get an additive, just like the Earth's velocity around the sun is having this stupid pressure, this acceleration added to it. A wobble would be the same thing. A wobble would be the same idea as you're just adding another acceleration vector, because at any specific point in the wobble, you're moving in a specific direction, and that's what's going to decide your new direction. So photons don't leave electrons reliably for that reason, and electrons don't move reliably for that reason. That's why they came up with the Heisenberg bullshit, is because electrons are wobbling. I don't do this little fucking shiny star crap either. Are you the same guy who did that crap before? Because I did warn you, right? I mean, everybody heard me warn him, right? Let's see, what was that asshole's name? Well, I don't see it, but I'll give you one more chance. Don't do this shit. It's obnoxious to a reasoning mind. You're just insulting everyone's fucking intelligence with that shit. Now, I could go into another theory I just thought of today, but I don't know if I want to do that. About the whole universe and how this energy just keeps consolidating, and how the universe could be preposterously old. And it's just over time that all of this pressure converts what the original universe was, which was just these force bits moving. And over time, the force bits have been compressed by a simple rule. So if two force bits hit under a certain circumstance, like one's this way and one's in the middle, and it gets crushed into this one or something. And just by a simple mechanism like that, where you could stick two force bits to each other, you can end up creating all the electrons and all the protons and all the neutrons and all that shit over time. But it's just because you're creating pressure. So you're just forcing all this stuff to get closer and closer and closer. And so each rendition of the universe, each time that, so it's like the solar system. I'm saying that the solar system was a bigger sun. Okay, it was in the solar system, and it exploded. And the fact is, when it explodes, it cracks. So you have this round thing, okay, and it explodes from the very center. The stuff on the outside doesn't break into little tiny pieces of dust. The stuff on the inside is all mushy, liquid, dusty stuff. But the stuff on the outside isn't. It breaks off in hunks and pieces. And those pieces don't have enough velocity to go very far. And so they end up just forming back into a cluster and just turning back into another solar system. And, of a much different variety. That is, this one has a bunch of heavy metals in it where the other one didn't. So this one has planets and all this kind of crap. But the universe itself is doing the same thing, and the galaxies are doing the same thing. And it's all just this slowly aging and getting heavier and heavier and heavier and more dense material. And so there's two arguments for the universe, right? There's this heat death thing where all the energy just escapes, or there's this idea that it creates more and more pressure, in the sense that all the pressure gets locked up in more and more efficient containers. Containers that aren't like uranium, they're decaying, but containers that are rock solid, like lithium or something. And, I don't know, helium. They have a half-life that's, 10 trillion years or something. And that eventually everything will be turned into that, it's kind of a theory. But anyway, it's interesting to think about it, just in terms of the pressure that's being created. Everything's just being pressurized in a sense. But this does imply that the external universe has to be a bubble, that all the energy bounces off of, because you have to sort of explain why all the energy just doesn't leave. So it sort of has to be reflected back into the system for it to get heavier, for the system to turn everything into condenser and condenser objects. Because it just doesn't seem like there's enough time, right? If you really look at this scale, 15 billion years, it doesn't really seem like it makes enough sense for their, what do you mean? So our planet's 5 billion years old, you know, our solar system, and somehow the dust from a supernova somewhere else got all the way here, right? Which has got to be far away. And that dust consolidated into a new solar system. It just doesn't make any sense, really, right? When you think about it, it's too far away. Then the universe has to be a hell of a lot older than 15 billion years. There's just no way that it could be just 15 billion years old, because there's no way the dust could get from another star to here in that amount of time. There's just no way. And if it was moving that fast, that dust couldn't consolidate. The dust has to be going very, very slow to be gravitationally attracted. So none of that crap makes any sense. It had to happen here. Okay, we're the byproduct of our own the solar system supernovaed, and we're just getting thicker and thicker and heavier. Each time it blows up with heavier shit in it, so the shit doesn't go as far. So as the stuff gets heavier, it doesn't move as far away, and so it consolidates more reliably, and so it just keeps expanding and contracting, getting heavier and heavier, more and more heavy metals. And maybe eventually the sun will be so heavy it won't even catch fire. You know, that kind of thing. The sun will be so full of iron and, you know, all the heavy metals that the sun won't even catch fire. But anyway, I don't want to, that's sort of a change of subject, but I have absolutely no evidence for any of that. It's just an intuitive thing. Well, I have some evidence that obviously it doesn't make any sense for dust to travel all the way here faster than light can. You know, that doesn't make any sense. Very interesting. I truly see what you're saying here. It certainly explains a lot. Thank you. I like it. Good. All right. I think I was overcomplicating things beforehand, but the idea of the bits moving in a continued in a loop, isn't that more to do with the nucleus? No. The nucleus is full of, the nucleus is creating the attraction for the electrons. And it's doing that because the neutrons are providing an escape valve for the pressure. So the protons hate each other. But if you put an electron between two protons, the two protons can get dead real close to each other. So the nucleus is full of these very close protons. They're creating an ability for the electrons, which are attracted to the protons, because it's the opposite force thing. All the pressure leaks out between the electron and the proton. All the pressure leaks out. So there's a real pull, in a sense, the external pressure. And there's zero pressure here. So obviously any external pressure feels like a lot of pressure. But the electrons still hate each other. So they have stuff ping-pong paddling between them. So the electrons are in a shape around. So just think of magnets, okay? All north-facing magnets, and you put them in a shield. You can see how they'll never get closer to each other. So if I put magnets in a round shield between two pieces of glass, right? Two pieces of glass, the magnets are all pointing north, and I push them into a circle. The point is I can't push one of those magnets closer to the center without moving the other magnets, right? So if the rule is I tie a string from each one of the magnets to the center, then you can kind of get the idea that that's the attractive force to the proton, and I can't violate that. So then when I push on one of those magnets with the strings tied, none of the other electrons will allow me to, because they can't move away now because of the string. So the pressure doesn't allow me to push the magnet in anymore because the other electrons can't pop out. See, that's what's holding the whole fucking thing together. So there's no orbiting. None of that shit is happening inside. Atoms are jiggling. They're just because the force is always inconsistent. There's a little more coming from this way, a little less. So everything's Brownian motion in tension. So an electron is sitting there being pulled towards the other proton, but it's being pushed away by the electrons. And it's just sitting there going like, I hate this fucking universe. I want to get the fuck out of here. You know, it's really not comfortable. Because the proton bits keep moving at right angles and therefore move in a perpendicular loop. Oh dear. Because the proton bits keep moving at right angles and therefore move in a perpendicular loop. Or perpetual loop. Well, the point is that there are no proton bits inside the nucleus because they all leak out of the protons. I mean, the electron bits. So there's no electron. There's no black bits inside the nucleus because they all leak out through the electrons that are part of the neutron. So the neutron's providing a relief valve. So all of the red bits, all of the proton hostile bits leak out through the electron. So there's no proton bits inside the nucleus. And obviously, if there was any black bits inside the nucleus, electron bits, they'd all be leaking out of the protons. You get me? So the nucleus is very bit light. Not too many bits inside of the nucleus. That's why everything's so frickin' close together, is because all of the ping pong balls have been ejected. And so now all the paddles can get much closer to each other. Where the electrons don't have that situation. They have no relief valve except to go through the proton of the nucleus and shoot it up to another electron. But there's no direct communication between the electrons. Their direct is with their neighbor. And if they want to communicate with some other electron, they're communicating usually through the protons doing the right angle thing or something. But clearly, it's all a balance of push-pull, yin-yang, low pressure, high pressure, high black pressure, low red pressure, high red pressure, low black pressure. It's just a combination of pressure that's holding the whole thing in tension. It's like you could think of it as springs, but I really don't want to fuck everything up. But you could think of springs that are being compressed where the electrons are. So the electrons have a compression spring, and the electron to the proton has a pulling spring. So the electron wants to go where the proton is, but the compression springs won't let it. If I make a hexagon, right, you can sort of get that I can't push any one of the points in, okay, without getting closer to these two. So if there was springs in a hexagon, you could sort of understand that you could never push one of the points in, because that means you have to get closer to the other 2 points, and the compression of the spring will say, no, you can't do that. And then the whole thing has to move. And if the whole thing moves, then the other electrons have to move, and you can't do that. And then they're going to be moving against the pulling string of the proton. So it's all just a balance of tension. Like I said, I could make it with magnets and 2 pieces of glass, and I could sort of give you the idea of it. But I should be able to just say magnets and a piece of glass so the magnets can't flip over. Just prevent the magnets from flipping over, and you can sort of understand they're going to create a tremendous amount of tension. So I could have a north-up magnet in the middle, and all the rest of the little electrons are south-up. And I could demonstrate that if I get them in a certain arrangement, even though they want to go to the center, they won't be able to, because of the tension between the other magnets. And as long as I got it just right, that pattern will be durable. Now, if I fiddle with it too much, I shake it or jostle it too much, it'll fall apart, the pattern will break, and all the magnets will fly into the center. But yes, matter is a trap. So an atom traps energy. And when you trap energy, you create pressure. So all energy is in the form of pressure. So that's all it is. There's just pressure, voltage, compression, moving things closer together than they really should be, or however you want to put that. Than they would be if they weren't in a specific arrangement that takes advantage of doing the yin yangs in exactly the right way. You can make things stay closer to each other than they would if they were free elements. But it clearly also creates tension. You can't move one bit without moving all the bits. So inside an electron are little subparticles. Yeah, well, I really didn't want to get into that. I wouldn't say they're subparticles. I'd say they're probably the same shit that the force is made out of. It's just that that piece of force has been neutralized in terms of its momentum. So it's like it moves the speed of light when it's free. But if I stuck two pieces together at their tail, now it can't move anywhere because it's got a rocket. It's got motion this way and this way. The two motions negate each other and has no motion. So I'm just saying the matter bits are probably, in my opinion, manifestations of the force where some nullifies the force's ability to go anywhere. So it's technically it could be all just an illusion of pattern. The whole universe has all these little bits moving, and when little bits pass at certain perfect ways, they reflect back exactly the same way, and then they reflect back exactly the same way, and then they reflect back exactly. So once they're in a pressurized container, the container stays pressurized. They'll just keep doing that. They'll just keep moving past each other, and so you could have a bunch of these little things moving past each other, and that would be an electron. But I don't, like I said, I don't need to go that deep. I mean, it's an insanely high resolution image. I mean, bent space is like, it's like 7 pixels per square meter, okay, of resolution. I don't really need to make an image that high a resolution to compete with that rubbish of bent space. And that's my ambition here, is to demonstrate how this push mechanism is so much more sensible. This particle push mechanism is so much more sensible than this silly field, bendy, warpy ether crap that physics has accepted, where particles aren't even particles. They're some kind of fucking wavicle. But if I have to answer your question, yes, the answer is yes, electrons have something in them that makes them three-dimensional objects. They can't be three-dimensional objects unless they have captured 3 dimensions of force. And force is 1-dimensional objects moving in 3 dimensions. And such. Oh, somebody else with little icony things. Jesus Christ, the emoticon. And it's not even a rational one. What does this mean? What the fuck does this mean? What does that mean? Oh, I'm number one? You're not number one. I'm number one. I hate distracting, trivial, rubbish, ambiguous, blah, blah crap. Just remove it. Do not emoticon on my board, please. Unless you want to do that little Hardy thing. Hardy thing might be okay. But everything else, fuck that. Oh, there we go. Are the gravitons, oh damn, effectively the same as the red-black force bits? Gravity, I'm not going to call them gravitons. Gravity is these bits without any specific frequency, and they're red and black soldiers. So it's a bunch of soldiers coming at you, and they're mixed. There's not all black over here and all red over here. No, they're all mixed up, and they're not coming at a specific frequency, generally speaking. They could come at a frequency, and they might create a little random photon, but they don't. By nature, they're not at a frequency. You know, it's constant frequency, a consistent frequency. There's not a consistent distance between them or a consistent separation between them. So they don't come at a specific and they're not separated by a specific distance. Some can be close, some can be far, all that kind of crap. So that's gravity. Now, you can take gravity, a tiny little bit of gravity here and there, and you can make light with it. Okay, that is you can convert it into red, 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 or black, 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 black at a specific frequency. Okay, and it's always black. That's the electromagnetic spectrum is the black energy because it's affecting the electrons. And then you can forget about frequency altogether and just segregate the force into all the red soldiers go this way, all the black soldiers turn, all the reds turn left, all the reds turn right. And now you have a magnet. So it's all the same soldiers, same force. So the gravity goes into a magnet, the mixture, and what comes out of the magnet is all the red ones are coming out this way and all the black ones come out this way. So it comes in mixed as gravity and it leaves as filtered gravity. It's still gravity, it's just filtered. And if the filtered gravity came to us, we would still feel it as at least gravity. Okay, so if we got hit by magnetism, we're really getting hit by a piece of gravity. It's still gravity. It's just gravity that's filtered. So now it can do even more. So it's the same force, it can just do extra. There's only one bunch of soldiers in the universe. One bunch. And all you're doing is, how am I going to manipulate the soldiers in terms of, am I going to have them orchestrate in some patterns when I spread them out into the universe. And that's all you're doing. So it's the same number of soldiers. Same soldiers create all the forces. They're just arranged differently. They're just in patterns. Different patterns mean different effect. I see. So all forces like gravity and EM are just different variants of the repulsive force caused by pressure differences. Yes. Well, obviously pressure differences can look like attraction, but yes, there's only from high pressure to low pressure. Things move from high pressure to low pressure. So yes, you can call it attraction, you can call it repulsion, it doesn't matter. They move in one direction, from high pressure, more soldiers, to less soldiers. All right, less soldiers is probably not the right way to say it, right? See, this is the catch. Because as I pointed out, the soldier can be trapped between an electron, one soldier. And obviously it's more pressure when the two things are close together, there's more hits, and the hits are energy. The hits are the manifestation of the pressure. So there's more manifestation of pressure, even though it's just one soldier. So I don't want to imply, you have to always remember that, it's only one soldier, but it's completely different. How much power that soldier has is completely dependent upon what the other soldiers are doing. So technically you could argue that it's still conservational in the sense that the only way this soldier can have more energy, that is get to a higher frequency of jiggling, is because a bunch of other soldiers hit these things from the outside to move them into each other. So it took extra soldiers to push the things together to make this soldier look more energetic. So technically, it wasn't this soldier being more energetic. It was because the other soldiers made it look that way. So in that sense, you still say it's conservational. You can't move things together unless you get more soldiers to push the jeeps together, kind of thing. But yeah, it all fits. I mean, it's just, like I said, last 4 videos I've made. I mean, it's just this argument. I shouldn't have to keep pushing this so hard, but some of these concepts you should be grasping by now. That this push thing is incredibly powerful. Once you decide to go push, I mean, it just answers so many questions. And I look, a huge part of it was recognizing the source of charge, the difference between electron and proton, and explaining just having the red and the black force thing, recognizing that the two forces interact entirely differently depending on electron and proton. I mean, that was huge. But I mean, the whole idea is just so simple. I mean, just force trap. It's a really important concept. Matter is a force trap. An atom, anyway, is a force trap. It can trap force, capture it. And the force has an angular momentum, so it's essentially trapped the angular momentum. A little piece of momentum has been captured. And, so that's one concept. And once you understand that it can trap stuff, well, then you can understand that it could filter stuff, because it could keep things in traps, and then it could release all the traps in one direction. And, it could do all kinds of things that create differences in the pattern of the soldiers. I mean, once you can trap soldiers, then you can have a line of random soldiers coming in, red, black, red, black, blah, blah. And once you can trap them, you could just keep trapping all the black ones, and letting all the red ones go through. And then one day you could say, release all the black ones, and you could just release them now as a laser beam or something, because you've trapped them. So let's see how long I've been in here. Maybe it's time to go. Things are slowing down as they do. Be curious if there's anybody else, more people in the room or not, during the day versus at night. Always seems to be about 15, 20. All right, so it is a bigger number. I haven't hit 20 in a while. So I guess afternoons might be a better idea, but I really hate doing videos during the daylight hours. It just seems like a silly thing to be doing. But it's raining, so that's why I'm doing it. All right, why is the angular momentum of the gravitons reserved? It's not reserved, it's conserved. That means that it's this idea that, let's see if a way to explain it. Say I had a ball bearing tied to a string that was on a loop. Okay, so the ball bearing can just spin on the string. Now, if I hit it with a ball and make it go around, you can understand that the whole going around part adds up to zero. Right? It's energy in opposite directions all the way around. When you add it up, it's angular momentum equals zero. But then you still have to account for the first thing that hit. You get it? So what's going to happen is when it spins around, it's going to go one ball further. Okay, technically. Obviously, it would just keep spinning is the point. It would just keep going around and around and around because it's going to keep doing that one ball more. It's going to keep just like it got hit again. So if I hit it once, it just keeps spinning if the rope is frictionless and all that kind of crap. And so that's what I mean by the conservation of the angular momentum is it always goes that one more. And that one more means it could hit another ball bearing in front of it and make it go out again. And once it goes out, this one stops. So once I restore the original condition, that is, don't interfere with this and just let it go straight through, you can see that's what the thing would have done. But if I catch this loopy thing, then it'll just loop and loop and loop, and this will not go out. But as soon as I stop it from looping, then this goes out. So that's the conservation of the directional momentum. All right. So why is the angular momentum of the gravitons reserved to conserve? Yeah, well, again, I don't really want to use the word graviton, but whatever. That's what we're going to use. Their angular momentum of the gravitons doesn't matter because they're unidirectional. They're all coming from different directions. So they already have no angular momentum collectively. Individually, they have angular momentum. Collectively, it adds up to nothing as angular momentum. It's just momentum in all directions. That's why the Earth feels the pressure from all directions. Right now, the Earth is holding captured energy going this way and this way in all of those directions. So it has opposite directions that it's got going inside of it right now. There's pieces of the Earth right now moving towards the center. Every bit of the mass of the Earth right now is accelerating towards the center of the Earth. That's why it's molten and hot, is because the pressure increases as you go, as you take the force lines that are further and further apart, like the divergent lines, and you make them closer and closer together. That essentially equals the pressure. So as you get to the very center, there's a huge amount of pressure. No gravity, but a huge amount of pressure. Let's see. I am a graviton, therefore I do not exist. Well, you won't exist here any longer. We really don't do inane poetry here. So, fuck off. If somebody wishes to get unblocked, you can send email to ds@draftscience.com and give me your channel name or your channel address, and I will consider unblocking you. Because I don't mean this to be personal, but I'm just saying, look, I mean, if I don't do reward and punishment, if I don't punish people for being assholes, then they'll just keep being assholes, right? There has to be a punishment. Don't do emoticons. Don't do trivial jokes. Don't do trivial poetry. You either ask a relevant question or make a relevant assertion or suggest a link or suggest something, but I'm not here to waste my time. I'm not seeking entertainment. A telephone call. We'll wait. I'll give you a few seconds more, a few minutes, a few somethings, a few pieces of time. Nothing? Come on. 20 of you. You should be able to do a little better. Yeah. All right. So I'll sum up. So anyway, so yes, so this video, I will attempt to enhance the description of this video as I find resources relevant to this idea of a push gravity. And there obviously is very few resources on the internet, very little conversation about how easy it is just to reverse Einstein by just saying, turn it around. Instead of pull, make it a push force. And it all works out just as good. And we have the evidence of the push mechanism in the cosmic background radiation. The cosmic background radiation is already screaming at you. There is push in the universe. It's saying it really out loud. Push is a reality. And all you're basically saying is part of that cosmic background radiation is called gravity. And we can't measure it when it's out there, but we certainly can measure it here on Earth. We can measure it. We can test for it. It's as real as that microwaves being bouncing around the universe. It's just as real. And so all I have to do is say the gravity comes from the same place the cosmic background radiation comes from, and I've answered all the questions necessary. And push satisfies all the mathematics. All right. Do bits always hit the Earth at equal intensity? Well, you should be able to answer that yourself, right? We know the momentum of a photon is always the same. I mean, it travels the speed of light, and it's quanta. That's what quantum mechanics means, quanta of energy. It's a quanta. You can't unquanta it. Doesn't split into pieces, doesn't change in any way. It's clearly they don't understand it as bullets at a frequency, but it's bullets at a frequency. Clearly, if I shoot 10 bullets in 5 seconds, there's going to be more bullets in a certain amount of time than if I shoot 20 bullets in 10 seconds. You know, I mean, if I shoot the other way around, 5 bullets in 10 seconds, it just changes the number in a specific amount of time, but the bullets never change. The bullets don't move faster. So if I pull the trigger once a second, or I pull the trigger once every half second, I don't change the speed of the bullets at all. I don't change the size of the bullets at all. So clearly there's no changing intensity. Or can there be discrepancies? Yes, no discrepancies. Quantum is a real thing. All the bits that make up force, the bits themselves are identical. The soldiers are identical. All the black soldiers, identical. All the red soldiers, identical. All you're changing is how you're arranging them. You can't change how fast they move. You can't change how strong they are. You can only change how many of them knock on your door. In a specific amount of time. guess we'll move on to the next subject and so forth and whatnot. Yes. I mean, I've been doing gravity for 4 videos, so I think I'll probably try to do something else, but we'll see how it goes. It's an important subject, clearly, and really just, I mean, the fact that there's just so little discussion about any other possible explanations besides Einstein's bullshit is just amazing how he has wiped the record clean of any other attempt to explain reality. I mean, he is just totally won. And it's just a totally God of the gap bullshit answer. It's just amazing how everybody has fallen for this shit. Oh, anyway. Amazingly disappointing. Amazingly a lot of things. What the hell is this frickin' window doing? Oh, that's the hide thing. Okay. Gotta be careful I don't load too much crap and everything blows up. So anyway, where are we at? 22 viewers. That's pretty good. But all right, well, you've had your chances and you have failed to save the day. Yes, okay, that was the last comment. So that's it. All right, so till the next time and such and so forth and whatnot. Such.